A previous video discussed the difference between a base 10 and base 2 number. We discussed the symbology and trying to expand your mind a little bit to help you better understand bases so that you can do translations fairly easy. This video is purely about how to change a binary number or a base 2 number into a decimal number, which is a base 10 number. For example, the number 100110. This is our binary number, and let's say we want to convert it to base 10. Well, the long way around is to first write the number out in long format using the powers of 2, as in the 2 raised to the exponent based on the position that the 0 and 1 is in, starting at 0. So for example, all the way on the right, this would be 0 times 2 to the 0. This is going to be 1 times 2 to the 1. This is going to be 1 times 2 to the 2, 0 times 2 to the 3, 0 times 2 to the 4, and 1 times 2 to the 5. It's important that you understand that's what we're actually doing, and the fact that each binary digit represents a power of 2, just like in base 10, each symbol represents a power of 10, except for the first one, which represents a single. Anyway, now binary is really easy because the mathematical rules tell us that 1, any number times 0 is 0, and we're just adding the numbers together. So I really don't care about any number that's multiplied by 0, so I can ignore all of those and focus on just the ones that have 1s. So if I get rid of all the numbers that have 0, what I end up with is 1 times 2 to the 1, 1 times 2 to the 2, and 1 times 2 to the 5. Now the second math rule is that anything times 1 is itself. So really I can ignore the multipliers as well, which just breaks it down to 2 to the 1, 2 to the 2, and 2 to the 5, or 2 plus 4 plus 32, which equals 38. So the first thing I do whenever I'm having to convert a number from base 2 to base 10 is write down the powers of 2, which is exceedingly simple. You just start with 1, which represents 2 to the 0, and you double the number each time until you get to as many digits as you need to translate the number. So with 1, 2, 4, 8, 16, 32, 64, 128, 256, so on and so forth. The number just doubles each time. So then to translate binary to decimal, first write down the binary number and overlay with the powers of 2 for each one, ignoring all the zeros. And then you just add those powers of 2. So, for example, 0, 1, 1, 1, 0, 1, 1, 0. If we line up the number with its powers of 2, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, so on, then ignore all the ones that have zeros and add them together, we get 2 plus 4 plus 16 plus 32 plus 64. This will work with any binary number. Just first write down the powers of 2 in order, ignore all the zeros, and add the numbers that are there. The easiest way to make sure that you can do this, and I highly recommend it, is to create some numbers from random zeros and ones. Go online, use your favorite search engine to search for a binary to decimal translator. Translate it by hand first, then put it in the program and see if your numbers match.